Today we are discussing about transport layer. Transport layer is the fourth layer of the OSI model. OSI means Open System Interconnection. It is developed by International Standard Organization. In this model, there are 7 layers. First one is physical layer. Second one is data link layer. Third one network layer. Fourth one is transport layer. Fifth one session layer. Sixth one presentation layer. Seventh one application layer. Today we are discussing about transport layer. Transport layer is the heart of OSI model. Below 3 layers like physical layer, data link layer and network layer. These 3 layers are called as hardware layers. And fourth one is transport layer. It is the heart of OSI. And fifth one session layer, presentation layer and application layer. These 3 are called as software layers. Here every layer has their own features. Physical layer in the form of data is bits. It's used in media, signal and binary transmission. Next, data link layer. It is containing data in frames. It is used in MAC and LLC. And network layer. It is a path determination and IP addressing. And next one is transport layer. It is end-to-end connected and reliability. And next session layer. It is a inter-host communication. And the next presentation. It is the data representation of and encryption. And next one is application layer. In this layer, network process and application. Now let us be discussing about transport layer. Why we are using transport layer? The transport layer provides reliability and efficient of end-to-end delivery of a message. That is, in order to achieve a goal, transport layer utilizes the services provided by the network layer, and transport layer establishes a logic communication. Transport layer provides 2 types of transport services. First one is connection oriented services. Second one is connectionless services. In connection oriented services, there are sequence operations. Like first one is connection established, and second one is information sent, and third one is connection released. In connection oriented services, there are more reliability and true delivery. Example like Bluetooth and share it. There is authentication is needed and the data is successfully delivered. Connectionless services is related to the postal system. It does not include any connection establishment and connection termination. Connectionless services does not give any guarantee of reliability. In these services, the data can be going in different paths and to reach destination. It's not need any authentication. Now let us see what are the transport layer services. The first one is end-to-end delivery. Second one is addressing. Third one reliable delivery. Fourth one flow control. And fifth one is multiplexing. Now we are discussing about end-to-end delivery. Transport layer acts as a true end-to-end layer. That is, it takes complete responsibility which device supervisor end-to-end address. See a figure. Source and destination. We are sending a message M1. The user available, the message has been delivered. Next, message 2. If we are sending but user is not available, then the message has been returned. Same like if we are sending a mail, if the user is not available, then the message has been returned or discarded to sender. Same like if we are sending a message from phone, if the another user is not available, if their phone is switched off or in airplane mode, then if the user come to normal position or remove from airplane mode, then our devices resend the messages. That is, the transport layer is always try to sending the message to destination. Second one is addressing. The addressing is looks like a post office services. Each and every electronic devices are containing their own IP address, that is IP address. IP means that is internet protocol. IP address is containing 32 bits or 4 bytes. Now we are using, see, there are 4 parts in IP address, 192.168.0.1 r. Each one is containing 8 bits, 8 bits, 8 bits. So there are 32 bits or 4 bytes. Network is containing 4 parts. Okay, these 3 parts are network. Another it is host. Now we are using 32 bits to 128 bits. Present generation is using 32 to 128 bits. Network administrator assign a IP address to each electronic device when they are connected to a network. When electronic device is connected to network administrator automatically assign an IP address. This is this device's address, and to assign it, the transporter can create a dynamic unique IP ID. The third one is reliable delivery. It looks as a controlling. There are 4 parts: error control, sequence control, loss control, and duplication control. Error control. When we are sending a data from source to destination, the data will be traveled from different types of network streams and mediums. The errors can be raised due to the network fluctuations. Error control. It detects the corrupted data and maintaining about loss of data and finding duplicates. Errors are corrections by using error correction methods. 1. Add parity, event parity, LRC longitudinal redundancy check, VRC vertical redundancy check, CRC cyclic redundancy check, checksum method, Hamming distance code. In sequence controlling, it's maintain number of sequences. It maintains sequencing orders. It should follow sequencing order. Say example live. We are sending first LIVA. It's become as a LVIA. It does not support it. It looks like it's become as LIVA. Next one is loss control. If any data fail to reach destination, the loss control detects the packets and sequence number. It identifies which is the missing segment and fulfill it. Transport layer performs duplication control by detecting duplicate packets. When duplicate copies of one packet arrives at the destination, the TCP should provide a mechanism to detect the duplicates. The next one is flow control. Flow control is the process of managing the rate of data transmission between two nodes like sender and receiver. Here fast sender and slow receiver. Slow sender and fast receiver. In these two cases, data will be lost. That time flow control acts as a regulating data transmission using congestion control flow algorithm and bottleneck algorithm. The flow control is used for regulating the data transmission. In these cases, both sender and receiver working in same path and same speed. There is no loss of data. In congestion control flow algorithm, the is using for overflow and underflow of data. This is a bottleneck algorithm. Here left side is our vehicles and right side is a narrow road. Before entering the narrow road, the vehicles are moving fastly. When entering the narrow road, they are going in slowly. The entering of narrow is the flow control. That's why I regulate the speeding of vehicles. Same like data transport. The next service is multiplexing. Multiplexing means switching from one network to another network using address table. Multiplexing is the process of combining multiple signals into one signal over a shared stream. In coming to diagram, here there are n inputs and it is one link but n channels. Where it is a link is a stream and networks are channels. So we are using different types of channels in only one link. Multiplexings are two types. One is upward multiplexing, downward multiplexing. Upward multiplexing means multiple transport layers connections use the same network connection to make more cost effective. Here, three transport layers using and establishing the only one network to reaching the network layer. It is a upward multiplexing. The second one is downward multiplexing. In this method, one transport layer connection uses the multiple network connections. The transport layer can divide it into different parts of network connections because of to improve the output of the data. This type of multiplexing is used when network have low capacity or slow capacity. Coming to diagram, either upper layer stack, this is a transport layer. It is divided into three parts. These three parts are network layers. It is a downward multiplexing. This video is the full information of the transport layer. Thank you for watching and please support me.